All right, so what I've done here is I've assembled some slides from the various lessons to try to help narrow things down a little bit for you for your review for the exam. This doesn't mean that what's in these slides is only what will be on the exam, but it's the vast majority. So just want to have that qualifier there. Um, the quizzes have all been posted for the week. They give you a pretty good idea of what you need to know for the exam if you want to pass. If you want to get a really high mark, you probably got to know a little more, but typically I pull the questions from that lot, so there shouldn't be too many surprises. Like I said before in the announcement, obviously some of the questions will be converted to short answer. Because it's a final exam and not a quiz, there will be time constraints. You know, we have to do this so that we don't have you just Googling up answers all the time. The purpose of an exam is to see if the information is in your head. So FYI, just so you know how things work at other places, my daughter's studying at McMaster right now, and they have to have their webcam on, and there's a proctor that watches them on the webcam. And if they deviate from looking at the screen, they are kicked out of the exam and they get a 0. So if you think that our system is onerous, then think again. Um, all right, so we looked at light and lighting crops after the break week, and that's where our course content continues for the final exam. So obviously 800 to 110 watts I discussed earlier was the sort of the minimum amount of light needed for photosynthetic activity to happen in a leaf. But of course, because plants are big and complex, we need typically around 500 watts to penetrate down into all the leaves. So that's especially applicable for high wire vegetable crops. Um, the other thing from Plant Science 1 you might remember is that very little of the light that hits the plant actually produces any sugar. So we're talking about a pretty inefficient system. So you got to make sure you get enough light there. And as far as green light is concerned, yes, plants are green because they reflect it. But look at this, 40%, that means 60% is still being absorbed. Um, so we look at that coming up. High light levels, anything over 1500 micromoles per square meter is typically going to burn your plants with solar radiation or photoradiation, photooxidative damage. But typically, 1500, that's really bright. Like 1000 micromoles per square meter is already pretty bright. 500 is plenty bright. So anyways, the idea is that we're looking at light is not just about photosynthesis, it also heats the leaf, right? And that heating of the leaf helps improve evapotranspiration, which cools the plant and also enhances calcium uptake, right? So light is a very important component of plant growth, obviously. This is just showing absorption of green, and typically green light is used in the lower leaves for some effective photosynthesis so that the lower leaves are not totally useless. Some studies have shown if you remove green from the spectrum, lower leaves can yellow sooner and fall off. So if you're worried about the aesthetics, having some green light in the spectrum might actually keep some of those leaves active. There's also interesting research that shows that green light which triggers the phytochrome response. Remember this from Greenhouse Technical, that can also be used to close stomata. So that can be interesting. I know some studies are underway looking at exposing plants to green light before they go into a box so that they don't transpire as much, which gives them better shelf life for a few hours, prevents the cardboard from getting moist, that kind of thing. So a lot of really interesting research coming down the pipeline for colors. We should clarify these terms: replacement lighting versus supplemental lighting versus photoperiodic lighting. So as we discussed in this lesson, replacement means the entire solar spectrum is replaced. That's suitable for indoor farming. Whereas in a greenhouse, the plants get full spectrum from the sun that they need. So we're just supplementing. So it's not essential to provide everything with our grow light in that context. Sometimes I think people are misunderstand the whole point of supplemental. And supplemental lighting needs to be as cost effective as possible. So you're not replacing every color in the spectrum. You're trying to get the most efficient delivery of light. Then, of course, photoperiodic, that means we're trying to influence photoperiod, and we know that we need very low light levels, so often a string of low quality light bulbs is sufficient, as long as there's some red light in there, right? Um, so some of the key rules around supplemental lighting. So it's more efficient to provide a lower amount of light or irradiation over a longer period of time than a high amount of light over a short time. So that means that, let's say you can supply 150 watts per square meter. If you did that for a long time versus, 500 watts for 20 minutes, versus hours, the plants will respond better to some extent to the lower intensity light over a longer period of time. And that is, we'll get back into that towards the end of this lesson as I review using high light levels and what happens to sugar that's being produced, right? So if you got very high light levels, sugar's being made rapidly, and sometimes it can't be taken away from the leaf fast enough and it gets trapped in the leaf. So when you apply just enough light to make all the leaves useful, you don't run the risk of just getting starch building up in your leaves and not having that sugar flow to the flowers or the fruit. So important to consider that. So the other thing is that as far as supplemental lighting, we get the best benefit, right, when we illuminate the plants beyond the normal day length. So that's another important caveat. Sometimes you see grow lights on during the day, certain crops that might benefit. Typically in the ornamental world, they would just wait for if it's an overcast day, if the sun is shining, obviously they're not going to bother topping it up. Even in the winter, they won't. They'll wait till the end of the day to extend it, or early in the morning. Generally, evening is considered a bit more effective. But especially in the winter, when light levels get below 100 watts per square meter or so, that's when we start triggering the supplemental lighting. And so that might even be when a cloud passes by. Typically in your computer system, you would set a delay time, because if you got a sunny day and the odd big cloud, big happy cloud floats over and blocks the sun for say 10 minutes, you don't want all your lights turning on, and then when the cloud's gone, then they turn off, because you just wasted a bunch of electricity getting them all up and running. So we do have to make sure our computer system is set up accordingly. Then we looked at different crops and the lengths of time that we can supply them with light. And cucumbers and roses were suitable for 24 hours a day. So now I'm not saying that it's economically viable. I'm just saying it's suitable. Tomatoes, 16 to 18 hours. They can't handle much more. They start to become necrotic. Continuous light, that's the same as obviously 24 hours. In many instances has negative effects on plants. Like I said, there's not many that can handle it. We see necrosis, we see starch accumulation in leaves, we see stunted growth. There's a lot of reasons why you definitely would not want to consider having lights on all the time. But tomatoes are particularly sensitive. So in terms of our vegetable course, that's one of the key take-homes. So yeah, up to 24 hours, we get less fruit and we get necrosis. We might even get crop degradation. When you're looking at peppers, up to 20 hours of light makes a difference. You get, lots more fruit, better quality, but the cost for the supplemental light for all those 20 hours is extensive. So there's very few pepper growers that illuminate their crop. There are some experimental regions, like farms that have a couple of acres under lights, just trying to learn to see if the benefit is worthwhile. But are you just growing larger leaves? Possibly. The increase in the fruit count and quality may not offset the cost of the electricity. So that's a really tough decision, and I think that the industry has not really decided yet what to do about that. Peppers with 24-hour lights, things go south. You get decreased fruit count, you get decreased fruit weight and size, so the quality deteriorates. Generally not recommended. Again, we talked about how you get starch accumulation in the leaf, and that doesn't flow to the fruit necessarily. So we have this sort of mismatch of source sink. Um, and whether it's a source sink or just a sugar metabolism, again, the verdict is still out. The two theories are there. Source sink being obviously that the tomato can't move the sugars out of the leaf fast enough, so they become stuck. The fruit's not creating enough of a draw or a sink. Sometimes if you are running longer light hours, you have to remove some leaves. So you don't have too many leaves causing competition for the flow of sugars and nutrients. But you don't want the sugars locked in the leaves. Then there's the sugar imbalance. The idea is that you're making sugars during the day, and at night the plants are supposed to process it. But if you never give the plant enough time to process, it can't keep up. So then the sugars get locked in the leaves. So it's similar to the source sink, but it's more related to physiological processing with this sucrose phosphate synthase, like these enzymes. They just can't keep up with processing. It's like having all your boxes from Amazon stuck in the warehouse. What are you going to do? You can't get them out. Then in the course, we moved on to food safety issues, and we looked at HACCP and Canada GAP and what those are. We talked about how the CFIA is responsible for administering inspections, the Canadian Food Inspection Agency. We also talked about how safety certification technically is voluntary. So smaller farmers tend not to become certified, whereas large wholesalers often are required to be certified. So if you're looking at a farmer's market, there's no certification there. If you're looking at a grocery store, they have to go through all the inspections to make sure that there's food safety is being monitored. The Ontario Greenhouse Vegetable Growers, which is a growers association, actually requires its members to be licensed. So that is something that, once a grower gets to a certain size, if they want to benefit from the marketing of OGVG or just the communications from membership or conferences, then they have to be part of that. But generally speaking, big growers are part of large grocery store chains, so they're already certified. So there's around 210 of those growers in Ontario alone. And then there's 36 that are both marketers and packers. That means that they don't necessarily grow, they buy from farms and put them into packaging and sell them. So, but a lot of the big growers are both growers, marketers, and packers. Smaller farms might sell to packers, for example. A lot of growers have gone with Canada GAP, which basically rolls in HACCP anyways. Typically, the major customer that you sell to would dictate what they want. I know Loblaws is Canada GAP. So what does HACCP stand for? It has nothing to do with USSR or Russia. So it stands for Hazard Analysis Critical Control Point, right? So this is sort of a checkpoint of items that are used to make sure that a farm stays food safe. And of course, Canada GAP incorporates all these things. And it's been around for a long time. The United Nations has a standard for food safety that's international. You might wonder, well, why would they? Well, because if you go to the grocery store and you walk around the produce department, man, it's like traveling the world, right? You got peppers from Mexico or grapes from Chile, lettuce from Argentina. I mean, it's a global industry, so it's not just locally produced. So we have to have some international standards to make sure that what is being eaten is safe. And HACCP is definitely the most common. It's been around since the 1960s, right? So the idea is that it sort of goes beyond just a final inspection of the food. It looks at the whole process, right, and tries to identify potential hazards and prevent them and fix them or prevent them from happening again. So, those hazards can be physical, chemical, biological, if a piece of metal gets into the food, or if bacteria are growing in the food, or if a cleaning chemical wasn't properly rinsed before food was put through the machine, that kind of stuff. We want to be able to catch that so that it's not consumed by someone. There's 7 major steps. I'm not going to go over that lesson in that detail, but you could look at it, look at some of the scenarios. I usually have a couple of scenarios on the final exam. So the first one is, analyzing, like, what are all the hazards? So basically doing an honest scope over the entire, from growing to putting in a box to shipping. What are the potential points where there's something can go wrong? Identify the points where you can control it or stop it or intercept it. And then at that point, you want to have what are called critical limits, so thresholds to make a decision. It's not enough to just say, well, just use your best guess, because when you have a big company, you need to have procedures in place, a clipboard with a standard. If you see this, then that. Because you can't rely on a judgment call. You need to have a defining limit. Because if you're going to hit the red button to stop the entire machine, people are going to be upset. They're going to want to know what's going on. And you have to say, hey, look, we were above the threshold. You don't want to say, well, I kind of thought maybe it wasn't safe. I wasn't sure. They're not going to like that. So they have actual critical limits, right? Then you need to have a system for monitoring. That's lots of clipboards and notes to monitor those, set tests, for example, like sending a dummy produce through a washer and stopwatch timing it to see how long it takes, and is it within the procedural time limits, for example. And then, of course, you have established corrective actions like hit the red button or divert produce to this bin for rewash later or whatever. Then there's also a verification process, to make sure that your corrective actions are making a difference. And of course, lastly, but most importantly, record keeping. That is so important because often food poisoning incidents turn into legal lawsuits. And that's where your record keeping is absolutely critical if you want to stay out of trouble. So, okay, so then we moved on to discussing alternative crops and some marketing stuff. Um, so we started off by looking at, so how do you assess the market, right? Uh, Say you want to bring something new to market, right? So you have to look at what we call features and benefits, right? So what makes your item stand out? Is it a unique variety or a cultivar of a vegetable or a flower? Um, does it provide a benefit like aromatherapy or something? Or is it a unique color that no one else has? Then you have to look at, who do you intend to market it to? Who's most likely to buy your product? Is it going to be a young person or an older person? Is it going to be someone in the city or someone in the country? Um, then you also have to do what's called the market demand analysis, or figure out, how big is the market? How many people are going to buy this? How many exist? Um, and you have to do these things honestly, because ultimately, if you're going to launch something, it's got to work, right? But then once you've got that figured out, you need to know how much product you need to meet that demand, and if you have the right facilities to do that. Um, we talked about places to sell, like farmers market or CSA, where people, deliver a basket full of produce. Direct to consumer retail, so dried or processed goods that are sold online. Maybe food cooperatives where different farmers aggregate their produce or their flowers together and then sell through the co-op. Then there's even tourism like lavender or hemp farms where people would drive from the city out into the country to look at your farm. So not only are you selling plants and maybe extracts, but you're also selling an experience. Then there's the organic certification. Sometimes maybe selling to institutions like hospitals or schools for food is an interesting alternative. And then, of course, lastly, there's the major avenue of wholesale, which typically requires large volumes and low costs. Um, as far as bringing something new to market, if you want to start your own little greenhouse business, the supply and demand rule, uh, you know, you can't avoid it, right? So the idea is that as supply increases and you approach the demand line, eventually you cross that, and that's when price starts to diminish, right? So the other thing is quality, right? If you're going to grow something, do a good job at it, because if you're doing a poor quality, you're going to get a lower price. And there's just no way around that. You can't force someone to buy your product. They have to choose to buy it. Then there's just the general, what we call product life cycle, right? So when you first introduce the product, there's exponential growth. And then as the product matures, it stabilizes and starts to slow, and eventually there's a decline. And typically, companies are actively researching new cultivars so that they have new products to bring to market so that they're constantly in a good cash flow state, right? That's why most companies have research divisions where they try to research and make sure they're bringing new, fresh things to market. And you'd be surprised at how much research happens even in the vegetable sector. They're constantly trialing new cultivars to see if they have better flavor or color, or sometimes they do multicolored tomato bins to catch the consumer's eye. You can't just assume you're going to be doing the same thing year after year for 25 years. It doesn't work like that. You have to constantly have an eye to the future and be doing research. Um, then there's in a typical day-to-day operation, you have to continue to reinvest in your business, right? So when you start out with a fairly new product where say there's high demand and low supply, you can charge a high price. And then as the market matures, the price diminishes. But let's say your cost of production was here to begin with. If you take the money you made initially, right? So let's take these profits that you made to start off with, and you reinvest those into machinery and efficiencies to improve your productivity and lower your cost of production, you can reduce your cost of your product at the same time as your price matures. So you constantly have a profit gap. And that is where other aspects of research happen at farms all the time. Looking at automation, packaging, spraying, harvesting, you name it. They're always experimenting to see if they can make a difference, and keep their costs continually lowering as the price pressure continues to decrease. Next, we moved on to diseases in veggies, specifically looking at tomatoes for the most part, but we covered some of the little more detail on the fungal and viral side of things. Typically, we also reviewed major points of entry into the greenhouse. I wanted to review this, right? Starting off with seeds being a common vector, right? So make sure you get your seeds from a reputable supplier and don't go for the cheapest one, go for the best quality one. Infected plant material if you're grafting, right? So the plant, maybe the knives that were used to cut the scions or whatever were contaminated. Birds, insects, these are also vectors. You'd be surprised at how many birds get into a greenhouse, especially in the summer months. And they'll be vectors for insects or even diseases and among them. Dirt on their claws, for example. It's astonishing what can happen. And then, of course, there's people like me visiting your greenhouse that might bring something in on our shoes. So a lot of greenhouses have foot wash baths that you have to go through to make sure your shoes are sterilized before you enter their farm. And then, another one that's common is the vents. In the summer, especially when you're opening your vents to keep the greenhouse at a normal temperature, if there's your greenhouse and the vents are open, obviously as air is exiting, that creates a negative pressure, which then can let air in at the same time. And so if there's bugs flying around, they can get drawn into the greenhouse and infect your crop. So that's another vector or entry point for fungal diseases and pests, really. Some common sense stuff that we talked about: sanitation, really important. Cleaning constantly. Growing resistant varieties, it's not always an option, but it's usually somewhat of an option. So you may have powdery mildew resistant cucumbers, but they may not be resistant to certain viruses. But if you can get resistance to certain diseases, that minimizes your overall headaches. I like to make this point that communicating with your staff is critical. If you've got 100 offshore workers in the farm managing the crop, that's 100 extra pairs of eyes that can be on your crop. And if you maintain good communication with them, they can let you know when they see something and you can go in and inspect it. Proper fertilization, that's another thing. If any kind of a plant nutritional disorder will predispose a crop to disease. Typically, a healthier plant is better. It's not perfect, but it's better at resisting infections, fungal and viral. Um, Having the correct climate that falls kind of into the same category as the correct nutrition. Same thing with water management, pH and EC, same thing. Pruning, this is interesting. With tomatoes especially, there's always plant management, right? And proper pruning with clean tools is important, or even just making sure you keep on top of your pruning so the plants don't become overly full of leaves and you get poor air circulation, for example. Um, Identifying infected areas, flagging them off, preventing staff from getting into them, and removing infected plant material. Really, really important. This is important. There's often flagging systems on a farm to make sure that if there's an infected area, staff don't wander into there. And of course, there is always good old-fashioned chemical control. We started with bacterial canker, or Clavibacter michiganensis. I bet you can guess which state they found that in. But in tomatoes, it can present on the fruit as spots, although often it shows up more in earlier stages on the leaves and stems as necrotic spots or wilting. So typically we remove those plants immediately. So wilting, this is cucumbers they're just wilting because their vasculature has been plugged essentially. So water can't get to the top. And sometimes it's on only one side because the bacteria are in one particular part of the vascular cambium and they wilt that side. This is what we thought was wrong with our cucumbers in the college. If you notice, a few of them wilted quickly. And it's a very common bacteria. It's found in our soil and it comes in on your shoes. And if you happen to be working with dirt, say you were out with Mary Jane's class planting the chef's garden, right? And you didn't fully wash your hands. You came in and worked in the cucumbers. Boom, Clavibacter. There you go. Later on, you get necrosis. So after a period of wilting, you start getting necrosis and death. So typically, we want to remove the suspected plants. So at the college, we've done that. There's a few that were left from last week, but yeah, whatever. Flag the area, keep people out, use clean clothing. Most farms actually require staff to wear uniforms. Which keeps more opportunity for pests and disease to get into the greenhouse. Yeah, we all want to minimize work, but I think the idea is that minimize work in the area of Clavibacter to spread it, so you don't get spread until it's totally under control. Sometimes if you do have to go into the area, you would separate the tools, so have a special bin, like maybe have them all in a bucket right by those rows so they're not mixed up with other tools. Yeah, this is probably one of the most important phrases. It's not a matter of if you're going to get it, but it's a matter of when you get it. And definitely at the college, we've had Clavibacter for a few years. Not last year we didn't have any, but the year before that we had a little bit. And then a few years ago, I remember they lost 2 whole rows to Clavibacter. But in a commercial place, you can see how that would be a big deal. And I think you've learned this in your pest management class or one of your courses, but agrophage is a effective virus spray. You just basically spray a bacteriophage, which is a virus that attacks bacteria. Agrophage is a commercial name for a company. You spray that on the base of your crops and on the leaves, and it infects any bacteria and will kill them. And a lot of farms will do this preventatively a few times in a crop cycle just to make sure that they don't get it developing on their crops. Now, interesting that tomatoes with specks were also in the Clavibacter, but in Pseudomonas you also get it. But there's a couple of things that help you to identify Pseudomonas or distinguish it from Pseudomonas from Clavibacter. So obviously sudden wilting is similar. But if you get hollow stems when you cut them open, but the biggest one, and this I think is the clearest, is brown discoloration at nodes. So if you look at the stem, you'll see it's kind of brownish black. There's some here, there's some here, there's a little bit on this one, this petiole. So those are your classic symptoms, some even here. That's all over that plant. So that brown discoloration is Pseudomonas, and if you cut it open, it'll smell bad because they use sulfur as an electron donor. So they produce sulfur kind of gas, which makes it like a stinky bacteria. They do also form spots on the leaves, so that helps identify a little bit, but the stems is probably your best bet. As far as botrytis is concerned, this is usually spread through cuts like knives or wounds from harvesting fruit improperly, and it's often related to climate. So high relative humidity or low vapor pressure deficit, that means you're not managing your climate properly, and so you're getting botrytis. It can be found in all parts of the plants. It typically starts out in dense, closely wrapped areas of the plant. Where air doesn't flow, you get localized microclimates. So growing tips and kind of moves in from there. Depending on how dense the leaves are, botrytis can show up on the tips of tomato leaves. That would start when they're young and unfurling, and then as the leaf matures, it would continue. So it's sort of establish at that small stage, and then as the leaf expands, it just becomes worse. Tomato leaf mold, or Fulvia fulva. That's a fun name to say. It looks a lot like a magnesium deficiency because it's in the lower leaves and it's intraveinal chlorosis, right? Which we would typically consider magnesium. So that's something that you have to be careful with. One of the things that will help you is that it's not always intraveinal. Like sometimes the veins go yellow too, but that's not an easy one. But one of the things I mentioned in that class, which is really important in general, is when you're identifying a virus or fungal versus a nutrient deficiency, what do? We look at the context. If you came across a tomato plant that had this variegated leaf, and you just walked past 200 plants that didn't, right? Are you going to assume it's a nutrient deficiency? No, because it's only one plant. You're going to assume it's fungal disease. It could be, there is the scenario that if the roots of that particular plant are infected, that they may not be efficient at pulling up the nutrients and you result in a deficiency. But in and of itself, if it's an isolated plant, assume it's a disease of some sort. These are some more pictures of the fulvia. You get sort of a brownish, almost purpley discoloration on the bottom of the leaves. So if what you do is you flip the leaf over, that's showing what looks like magnesium, and if you see this brown discoloration or purpling underneath, then you should assume that it's tomato leaf mold. Then we discussed fusarium, right? If we cut the stem in half and we see that sort of light tan colored inside the steel, then we know, or the cambium, then we know that we have a fusarium issue. Of course, the plant would be presenting with wilting. There'd be no obvious markings on the stem, like an entry point for the fungus. It would go in from the roots and go up through the stem. That's typically how fusarium works. So there's your root entry. You can see that there's not a lot of small roots. There's just the large ones. The rest of them have succumbed to the disease and sort of rotted off. Here we go, we're cutting the stem sideways with a knife to see, and you can see the brown cross sections of the cambium to identify the fusarium. If you have new growing seedlings and you get black or dark brown collapse at the base of the hypocotyl on the seedling, that is damping off. That's often rhizoctinia or pythium. Most of the time it's related to you growing too wet. So be very careful that you don't overwater your seedlings. Very, very critical to get the water just right. We spent some time talking about viruses, the different kinds. I'm not going to go into what they look like because they all look very similar, but we do want to remember that the major vectors for viruses are piercing, sucking insects, right? It gets in their saliva, and when they move from leaf to leaf, they spread the virus. So we have to isolate, remove, and eliminate vectors. Those are the things you should remember for the exam, right? What are the main sources of entry and how do we control them? There's one picture, tomato mosaic virus, which looks like, you could say, oh, it's a boron and iron or zinc deficiency or something like that, but it's viral. So, yeah, other means of controlling viruses, common sense, like we discussed with other diseases, clothing and tools need to be cleaned. We need to remove organic matter or dead leaves, proper disposal, so burning and not composting. Um, or sometimes they wrap them in garbage bags and put them into a dumpster without opening the bag. But cleaning between crops is absolutely critical. Don't let just anyone in the greenhouse. Limit it, right? And we know that we've had a hard time getting into greenhouses because of human viruses, not tomato viruses. Again, clothing, we already mentioned this up here. Washing your hands often, just like with COVID, honestly. I mean, we've lived this nightmare long enough, it should be secondhand. Uh, I did mention that milk is functional as a disinfectant because the casein proteins will actually bind up the viral points that would look for the plant tissue. So spraying milk, even though it's not done commercially, is an interesting organic approach, just so you know. And of course, exterior of the greenhouse, weed maintenance. It is always important. You got to keep your farm clean because weeds can be hosts for virus, and then you get a thrip on that weed, and then it gets in your greenhouse, and boom, next thing you know, virus. Okay, so lastly, we talked about mushroom production. This was a this is always a fun lesson. It's too bad we can't tour the mushroom farm down in Leamington, but if you ever get a chance, you should do it. It's pretty cool. Anyways, this is the sort of typical life cycle. Uh, Normally, we're adding spawn, which essentially is this stage growing on some seeds, like corn kernels, that you inoculate the medium with, and then they will grow and produce these sporangia uh, structures that you see. Think of them as a flower, kind of like a flower stage. And these hyphae, all these white strands of hyphae are what you'll see growing in the mushroom compost. Um, so most farms that grow mushrooms, they spend most of their time making compost, which is really interesting. Very specialized compost mix. So starting with things like straw, sometimes they use corn cobs or cottonseed meal in the southern states where they got lots of it. But straw is mostly what I've ever seen. Then mixed with manure, but ideally manure that is bedding from horses. So that's straw and horse manure, which is high in nitrogen, which is what we need for the fungus to grow properly. It's like a plant in the sense that it has its nutritional needs, right? So sometimes they have to supplement the nitrogen up with some chicken manure, or sometimes they even add synthetic urea if they're not concerned about being organic. And then there's the controversial gypsum, which they raise to all mushroom compost to raise the pH and provide calcium for the mushrooms so that they can form proper mushrooms and not be soft or undersized. Um, Again, this is just a diagram showing all the inputs into making mushroom compost and some of the problems, things like leach, water, and soluble stuff that can come out the bottom, maybe some emissions issues, dust and smell in the process. A lot of mushroom farms really smell, and it's really only one stage that stinks, and it's the initial compost just to get it up and running. And after a short time that goes into the chambers where they finish them, they don't smell so much anymore. This is a picture up here. This is the front end loader dipping a massive bale of straw. They use the mega bales, and they dip them into the honey pond, as they call it, which is basically this bubbling pool of bacteria that hasn't been touched for years. And they, as far as the mushroom farm is concerned, it just gets better with age. It's heavily oxygenated. You'll see there's bubbles coming up in these pool areas everywhere, and that's to make sure that we have aerobic bacteria growing in there. So once they've dipped the bales of straw, then it's time to mix them in with the other components. And then they have them often, either they have them in a large bunker and they just turn them with a front end loader, or they have an indoor area like this, almost like a greenhouse, where the straw is mixed with the manure. This is a moving machine that has arms with tangs that spin and blend the compost as it drives along the compost pile, or windrow as they're called. Um, Either way, they have to mix it thoroughly and let the bacteria start doing their thing. And at that point, heat starts to build up, just like your compost lesson from Plant Science 2, if you remember, from all the bacterial activity. Remember, the bacteria are feeding on things like the straw. That's the main carbon source of nutrients for the bacteria, and they pull the minerals like nitrogen and phosphorus and potassium from the manure in the surrounding mixture that you've put in the compost. Eventually, it moves into the finishing room where the air is blown into the floor to aerate it, and they also try to keep the moisture in there. And this is a finishing room, so it's a massive. You can see the height of this person; it's pretty big. That gets packed full of compost, right? Big, big block of compost. And there's slots in the floor that blow air up through it, and they can do that to regulate the temperature, to provide oxygen, or sometimes they even have to introduce steam when they're done to fully sterilize it. But if you remember from Plant Science 2, the compost gets hot enough just from the bacterial activity that it kills off all the bad bacteria, and you end up with something that's perfectly safe. And of course, one of the main reasons is we don't want to have the wrong fungus growing in our compost when you put it into the growing racks. So we try to keep it as sterile as possible. And this is a machine. They're pretty specialized. They look quite complicated. This is how they load the growing rack. So it's interesting. Each of these rooms is similar in size to the compost room that I just showed you in the previous slide, but inside it's full of rows of shelving. And this device has a dispensing tray that can go up to the different heights of the shelf, and it will load each shelf with the correct amount of compost and spawn and casing. So it sort of like rolls it out and fills each trough as it goes along. They're pretty cool in how they do that. So the idea is that your compost goes in the bottom of each shelf. So let's say this is my shelf. The bottom gets compost. So it's coming off the bottom. And immediately above that is the spawn, and then above that is a casing. And so that the entire shelf becomes that continuous sample, a sandwich, I guess. There you go, a picture of the machine dispensing it. And then, of course, there's the spawn, which is the hyphae growing on some corn kernels or oat or wheat or barley. This is a nice cross section showing the compost, the spawn, and the casing, which helps keep moisture in, creating a barrier. You can see the nice different color transition here as well. And of course, eventually the hyphae fill the entire thing. The fungus starts producing CO2 from breaking down the straw, and that CO2 can get quite high, 10 to 20,000 ppm. You got to make sure you're not in there or you'll suffocate. And the grower can monitor this by looking at CO2 readings. And eventually they get to the point where the fungi start to produce the fruiting bodies, which is the mushroom you would buy at the store. And so at that point, the grower's job is to maintain anywhere from 800 to 1500 ppm of CO2. So they just turn a fan on to vent it, and they can also provide heat in the winter months. So their job is to maintain temperature, relative humidity, and CO2, which is a lot like what we do in a flower or a vegetable greenhouse. So they can regulate the growth. Otherwise, they end up with poor quality. They might end up with the too many mushrooms or too big. So it's their job to sort of throttle Anyways, and in the end, after up to 3 weeks of harvesting, and then you rip it out and start again. And it's a non-stop process. They're in continual production year round. It's pretty cool. All right. I wish you the best of luck on your exams, and email me if you've got any questions. Take care.